Hello. In this video, we're going to go over Python classes, specifically inheritance and some fancy methods called Dunder Methods, which is not Dunder Mifflin. You know? Anyways, let's get to it. All right, so in order to go over inheritance, I was thinking of how I could do this with Pokemon, and I don't know if it makes a lot of sense to do with Pokemon. So instead, we're going to do it over people. So we're going to make a class person. So this is just a class where during its init, it takes in self, and then it also takes in the name and the age of a person. Then we do self.name equals name and self.age equals age. Now, we have different type of people, right? Every person, maybe, if you're, everybody has a name, probably, I think. Everybody has an age. So there are different types of people, though, right? There are different types of professions, different types of things. So let's say that we also have a developer person. But this developer, like you or I, is another type of person. So what we can do is we can inherit person, all of the attributes and things that the person class has already. We can inherit that as our new developer class. And what that means is that we actually get all of this, well, all of this being the name and the age, for free. Because say we now want to add some like increase age method or something, right? And we do like self.age plus equals 1. If that's something that you want anybody who's a type of person to be able to have this super helpful method, then if they inherit from person in any way, then you can actually just use it just like that, because you're already going to get it because you're inheriting from it. So let me show you exactly what that means. So for a developer, we still probably need the name, and we need the age, and maybe we need like their language, right? What's their best language that they're in? Like Python or JavaScript or whatever, not English or something else. So we could just do self.name equals name, self.age equals age, right? And this would work because technically, because developer is a type of person, even if we do, let me just show you. Let me go ahead and get rid of this. Oop, get rid of that. Whatever. We'll just, I don't know why that popped back up. Okay, let's do Jake equals developer, and we'll do Jake 32 and Python. And then let's do Sammy, which is not a person, but she thinks she's a person. Her name is Sammy, and she is 5. Now, if we do print Sammy.age, and then we do Sammy.increaseAge, and then print Sammy.age, we can see that when we run this, we get 5 and then we get 6, because that makes sense, right? We have the person class of Sammy, and we're initializing it, and we are calling increaseAge. Now, if we do the same thing for developer, or for Jake, then when we run this, we're actually going to get 32 and then 30. But how does that make sense? Because we didn't actually call this. We just called this here. But the reason this makes sense is because effectively what's happening is like in the other video where I was talking about how if you have a class variable versus what's it called? Like a initialized variable, an instanced variable. The class variable is kind of checked on after the fact. So it first checks to see if there's an instance variable with the instance of your class. And then if there isn't one, it checks to see if a class variable matches it. So that's the same thing that we're kind of doing here, is it's checking to see when we call increase age, it doesn't exist on developer. So it's going to look and say and see, nope, it's not there. But if we go ahead and if it then goes and sees, oh, okay, does developer inherit anything from anywhere? It will see that it inherits it from the person class, and it will go ahead and see that it now can reference the person class is implementation of increase age. So technically, we don't actually need to do these two things. So not exactly. We still need to do them, but we can do them so that we're reusing what person has. And the way we can do that is by using the super keyword. Let me just add in language here so that we don't forget that. So the super keyword allows us to do super brackets dot underscore init name age. Now, if we do that, we can actually get rid of these two lines. And if we run this again, we can see we get the exact same result. Because basically what's happening is when we call super init, super is referring to the super class. What are we inheriting from? So super here is actually referring to person. So if we were thinking of person, if we just call this like person, and then we're calling init, then we're calling the init of our inherited class. So that's kind of how inheritance works. So it can inherit not only the super method, but we can inherit the other methods that they provide. Now, what if you find your bone? Go get it. It's not a real bone. It just squeaks, which you can probably hear. So, sorry. Okay, so now say we want increase age to do something different. Maybe we don't just want it to increase the age by 1. Maybe we want to be like, I don't know, maybe we're nerds about it because we're developers and we want to be more specific. So maybe we want to say like def increase age, and then we say by like how much, and then but we default it to 1. Now, if we do this, we will actually just do age plus equals amount. But this is actually creating a new version of increase age because there's now an input. So really what we'd want to do is just do this, and now we can say like 1.05 or something. Maybe we do 1 plus 1 divided by 12. So every month we add another bit to our age. Because we're like really nerdy about it, I guess. So let's go ahead and run this. Now we can see that we are, we don't want that 1. Now we can see we are 32.833 0.0833 repeating, obviously. So that's great, right? Now we're calling this, and we're not actually calling this. So this is what's called overriding a method, because we are overriding what our parent or our inherited method is doing. So technically we could just do like super dot increase age, right? We can still reference the same thing, increase age. I don't know why I couldn't type that. And if we do this, we could then just print like developer age increasing, and then we could run it, and we can see that we get developer age increasing, and we also get the new age because we called the super version of increase age. So that's just this really simple example of how you can override methods. But another cool thing is that you can actually do multiple forms of inheritance. So even though we now have a developer that's a person, we could have like maybe a machine learning, I don't know, like ML expert, and they actually inherit from developer. So now what we can do is actually have this chain of things that inherit from different types of, in this case, people and classes. So the reason this is really powerful is because you can kind of break things down into like their really basic parts, and implement them as much as you need to. But you don't really need to be specific and like redo that for every type of thing that could inherit from that, right? So in the case of like a person versus an ML expert, they both have like a language that they probably use the most, and they're both people, so they would both inherit from person. But ML expert is a type of developer, so now we're going to inherit from them, which also inherits from person. So it's pretty cool that we can do this type of stuff, and it's honestly really powerful. But we can also just do Pokemon trainer, and this can inherit from person. And then maybe this should have been my example instead, to stay in the Pokemon theme. But we can say like name, age, and then super init, name, age. And then we could have like a class, Pokemon or gym master. What are they called? Gym trainer. I don't know if that's what they're called. Pokemon trainer. And then you can have another one, right? So you can kind of just keep doing this where you can continue to expand and make more specific types of different types of things, where they can each have their own implementations. So I think it's really cool. It's not something that you're necessarily going to need for like every program you make, but being able to kind of identify when you can create these super classes that your other classes can start inheriting from is a really great way to kind of like skyrocket your proficiency in different languages and kind of just make yourself a better programmer. Because like I've said in some of my other videos before, one of the number one things to kind of recognize a really good programmer from an okay programmer is like, are they reusing their code, right? Are they writing the same thing like a dozen times? If so, it's kind of not great, right? Because now if you need to change something, you need to change it a dozen times. Maybe you'll forget one, and now that you have a bug. Bugs are bad. So this type of stuff will actually make it so that bugs won't happen as often because you're only referencing a single implementation and you're referencing that everywhere. So classes. All right, so this is just, I know this was like maybe really basic, but this is, I think, all that you really need to know for the basics of inheritance. You can have multi-inheritance, in this case of Pokemon trainer or gym trainer, how they chain multiple times up. In Python, you can only have like a single chain of inheritance. So you can't have like a gym trainer inherit from Pokemon trainer and from developer. That's something that some languages can do, but as far as I'm aware, Python does not support that. Maybe there's ways around that I'm unaware of, but if there is, let me know in the comments down below. All right, so that's inheritance. I hope that makes a lot of sense. Now, on to some special fancy methods called Dunder Methods. What the heck is a Dunder method? Well, a Dunder method is actually something that is really, really is kind of useful and kind of makes it feel like your code is like really ingrained with Python itself. Like it's not just like it's not like you're building on top of it, but you're like making it work more normally. So let me show you what I mean. So let's maybe change language here to be like salary. Okay. And let's say our salary is like 50,000. Okay, so now if we go ahead and do salary, I can spell. We don't need to print it twice. And we can just make sure that this is working. Excellent. We see our 50,000. Now, let's get rid of these Pokemon trainers. Okay, so now, and I'm going to get rid of this override method just to keep things clean. Okay, so now what if we want to make it so that maybe I want to increase my salary, but I don't really want to just like do like, Jake.salary. Like I could just do Jake.salary plus equals like, 50, right? And now I'm 50,050, right? That's something that I can totally do. But what if I just want to make it so that because because companies sometimes just think of people as numbers. What if we want to just be able to say like Jake plus 50? So we're going to say Jake is now getting $50 more. Well, if we do Jake plus 50, we're probably going to get an error, right? Because actually here, let me just do Jake.salary and Jake plus 50. We get an error because it's saying unsupported operand types for plus, developer, and int. So what the heck does that mean? It's basically saying that it doesn't know how to handle the case where a developer and an integer are having the operand plus applied to it. So it doesn't know how to add 50, which is an integer, to a developer. So we can actually make it so it does know how to do that, which is kind of neat. So we can actually say def underscore underscore add underscore underscore, and then self, and then other. And what this is allowing us to do is this is allowing us to make it so that when the plus symbol is used, whatever other is, we can apply it to ourself. So in this case, we can just say, we're going to assume that it's always just going to be another, like, it's just going to be an integer. So we can just say self.salary, I can't type, plus equals other. So if we do this, we should now be able to run this code. And when we can. So we get our 50,050. But the reason this works is because we're basically added support for the plus operand. Now this is called a Dunder method. Dunder basically, I think, is because of these two underscores on either side, which is same with an init. So this allows us to say, like, how do we support the plus method? And there's the same thing for the minus. I think is it minus? Other. And then we can say self.salary minus equals other. I think this will work. Jake minus 100. Maybe it's not minus. Subtract. Sub. It's probably just sub. There we go. My bad. I forgot that one. All right. So now we can basically add things or subtract things. But another cool thing you could do here is not actually only make it so that you're adding like a number, because maybe we don't want to do this. Maybe we want to do Jake plus Jake. So even if with the Pokemon example, which I think is a really cool one, is we could make it so that if you add Bulbasaur to a Bulbasaur, maybe you get a Charmander, or not a Charmander, maybe you get an Ivysaur. So I think that's like a really interesting way of like thinking about how do you, like, if you were to make something like a Pokemon game, how do you evolve a Pokemon with another Pokemon? Well, you're kind of adding them together, and you're kind of taking stats from one to another to like make another Pokemon, right? So I think that's kind of like an interesting maybe use case for maybe playing with something like this. But I digress. It's just kind of a fun thing to think about. So another one that's actually really useful is the string. So what happens when we print out just Jake? We get this main developer object stuff. And well, it's kind of terrible, right? This doesn't mean anything to us. So what we actually can do is do def underscore underscore str underscore underscore self. And then we can return what we want the string to be that is a representation of our object. So we could then say f self.name is a developer with a salary of self.salary. So now if we print it, we get Jake is a developer with a salary of 49,000. So pretty awesome. So there's actually another method that is called REPR, which stands for representation. And representation is actually what type of string should you return to a developer who's using your code versus a user who's going to see the output of trying to print out your object. So in the case of like a normal user, you'd want to use string. For the case of a developer, you do want to use the representation. So maybe for this, we would return f developer, and then you do like, oops. Then you do self.name. I don't like that. Age, self.age, and self.salary. But if I run this now, we're going to see that we are getting the string. If I don't actually have a string method, we fall back to the representation. But how do I specify that I actually want to reference the representation instead of the string? Well, the reason that we're using string here is because when we try and do this print, it's basically doing print string of Jake. And when we do that, it converts it to this. Now, the reason it's doing this is because when we print, we're trying to print a string. A string is just, characters that looks like text. But if we wanted to do the representation, we can just do REPR, which is the representation. So obviously that is kind of what maps to these values here. So if we print this, then we can see that. So that's kind of a simple way of how you can kind of differentiate, but it will always try and do whichever one it's trying to reference. So because it's this Jake class is trying to be cast to a string, it will reference this one here. Now, one more thing that I think is really useful is being able to determine whether one object is equal to another object. So say we add Jake equals Jake, and we go ahead and do this. This is true. But how do we know this is true? What if I do Jake equals Sammy? And maybe we say that Sammy is also a person, and she also makes $55,000. Well, if we print this, we get false. But how do we know this is false? What if we want whether one is equal to another because we're a corporate company and we only care about numbers? Just as an example. Maybe we want to check based off of salary. So we could do like salary equals Sammy.salary. Well, okay, false. Okay, that's fine. But how do we know that, right? We know that because we did dot salary. But just like when we were doing our minus or our plus, we want to make it so that, when we're referencing these developers, we really just care about how much money they're making because we're super conceited or we're greedy. So what we could do here is actually just do def equals self other. And all we have to do here is return self.salary equals other.salary. Okay, so this case, we're referring to another type of developer. So that way, when we run this, we can get that it is false. Jake and Sammy are false. But if we set that Sammy is also making 50,000, and we run this again, we get true because now they're the same. They're the exact same. One is because they're both making 50,000 as their salary. So that's kind of an interesting way of how you can kind of interpret, like maybe for unless you actually have the exact same object, like even if I do this again and I didn't have this, Jake 2, this should be false, right? This is false because Jake 2 is a different version of Jake. But if you look at how that's in, like what it actually contains, it's the exact same thing, right? So if you wanted to just say like, oh, well, if it's equal, should just be like, does it have the same name? Does it have the same age? Does it have the same salary? You can do that here by saying like, self.name equals other.name and self.age equals other.age and self.salary equals other.salary. Now, if we run this, we get true because they're effectively the same. So even if we don't want to just be super greedy about money, it's still super useful. So a few others that I'm not actually going to kind of go over, like implement, but just to let you know that they do exist. are these here. So we can do underscore underscore NE, LT, GT, LE, GE for like not equals. Check if something is less than, greater than, less than or equal to, or greater than or equal to. So you can kind of make it so the class that you implement works with like the underlying like concatenation or subtraction or, equality checks that Python can do. So it's a really powerful thing to be able to kind of like supercharge your class. All right, so that's it for this episode of Python classes episode. I hope this made a lot of sense. If it didn't, please drop any questions you have in the comments down below or in our Discord, which is also in the description. Happy to help. Also, I have started streaming, so if you want to come check that out, I've been streaming on Wednesday. I don't know if that's going to continue to be the case, but subscribe so you can know when that happens and click the little notification bell. So that's all for this one. In the next video, the finale of Python classes, we are going to go over decorators and custom decorator types. So should be a good one. So make sure to subscribe to check that out as well. All right, I will see you in the next one. But remember, I'm Jake, you're awesome. And this has been Python class inheritance and Dunder methods. Cheers.